Here comes a demo of IQtree, which is probably your best option for doing maximum likelihood phylogenetics. We do have ML even in Mega, but in practice, this server has a 128 node supercomputer and better algorithm, so it's much quicker than running Mega in your local computer. So to start, you need to choose the web server in Austria. That's the real home site of the software, and that's where they have model testing. You can see that the server load at 7% gives you plenty of chances to get your work done. And now here for the model selection, the good thing here is that they have the automatic option, meaning that they perform model testing and choose the best model for running the analysis. And so what I'll do is to start with an alignment file, go for my MSA practice data in aligned FASTA format, and then choose Go. Oops, come on. Email is a good idea, so you'll have a link to the results even if you leave later. Now it's been submitted, and let's cheat a little bit. I'll just jump into my results. In the status, I could have seen when the various steps of model testings proceed, but in actual fact, what happened here was that this whole thing was over in 70 seconds of CPU time and 71 seconds of wall clock time. So that was really quick, done in 1 minute. When I tried model testing in Mega, I was able to complete just the model testing for the same data in about 10 minutes. So this is quick. And now what we have here in model testing is all models they have for amino acid alignments, and this is sorted by their information scores or information, I forget to see, information content, I believe. They have different criteria. Sorry, that's information criteria. They have Akaikis information criteria and Bayesian information criteria. And as it is now, this has been sorted by the big scores. But if you look carefully, you can see that it's pretty much the same three, which are the top three. And looking at how this would have ranked in comparison to what I would have chosen myself, knowing my alignment. So it's exactly the same thing I would have chosen. So being uncertain, maybe the first and third would have been my two options. But anyway, WAG, the Whelan and Goldman model is thought to be the best one in protein phylogenetics. And because this data has some invariant positions, we need to have +I. And this G4 means that it has Gaussian distribution in 4 discrete categories. And the shape curve of the shape constant for the Gaussian distribution is also selected by the model testing algorithm. And the other option, including frequencies from my own alignment data, that would have been pretty high ranking, and I think this is the smallest value for this other information criteria selection. And then here are the results of the estimated best gamma value, meaning that it is using 4 categories, dividing all the non-constant sites into just 4 categories based on how variable they seem. And in practice, this means the same thing as partitioning your data, so that our columns are divided into 5 different sets, one which is constant columns, obviously without much information there, and then it is the variable columns in 3 different categories, from the least variable to the most variable. And these 5 data sets are analyzed separately so that their likelihoods are calculated with different parameters to find the maximum likelihood for the whole alignment data. And in the end, we have the ML tree here. This is the first tree, which is counted without bootstrapping. And it includes the bootstrapping values, but the topology is the one which is for the original tree. And you can see that it's quite similar to the tree we have been seeing with minimum evolution methods, but there is a difference in where this protein tyrosine phosphatase group goes. For comparison, let's see the tree in Mega. Oops. There we go. So that one has the PTPRZ group together with the CA4, CA15 group here, whereas in the maximum likelihood tree, it is outside of the others, except for the group of cytoplasmic CAs and these enzymatically inactive CA-related proteins. But anyway, no big differences there, as expected, because this is pretty clear data with a strong phylogenetic signal and well-aligning sequences, no really far away sequences in the data set. And then one important thing to notice is that this one line, which is very long, is the text presentation of this tree, which you may note is pretty ugly when it's printed with just normal text characters. If you want to draw a tree with the interactive Tree of Life program or Archaeopteryx or some other software, so you need to save this file and save it as something.tre, short for tree, as you may guess. And then the other tree which we have is the consensus tree, calculated from 1000 bootstrap trees. And this is almost indistinguishable from the original one. So it seems that the ML did a really good job, and we have a really good data set, so that the resampled data sets give pretty much the same trees. And so the only thing where we can see the kind of deviant trees is that not all node values are at 100%, but many of them are more than 90%, and this is one of the weakest at 55%. And what else? No other poor nodes. Here's 58. So every single node is above 50%, so that is really a good result here. And by the way, CA10 has been used for rooting the tree, even if this is an unrooted tree, but software has inferred that this is the most different sequence from everything else. So it's made the informed choice of putting this as a root, which would have been my personal choice for the outgroup as well. So maximum likelihood is really good, and just let me show you the results of model testing from Mega. As I said, this took about 10 minutes, and it has less models than IQtree has, but again, the Whelan and Goldman with Gaussian distribution of variance allowing for invariant sites is the top one. And it doesn't have all, but anyway, the other option, which would be good to choose just from the top of your head, would be Jones Taylor Thornton with a distribution of variance between site, because or distribution of rates of evolution between the sites. But this is it. This should have you up and running to do maximum likelihood phylogenetics. And I'm repeating my recommendation for IQtree because it's so much faster. With bootstrapping, with a data set big like this, it would be hours and hours, maybe even overnight with Mega, and 70 seconds in IQtree server.